Okay, this is number 6. Write 3, 4 in polar form, round numbers to the nearest hundredths. So we are going to first of all graph this point 3, 4. That's 3 to the right and 4 up, and there's the point. And now we're going to draw the line from the origin to the point, and we're going to put R because that's what we call the radius, and we're going to show the angle theta. All right, so we need to find out what R and theta are so that we can write this in polar coordinates. So first of all, we can use the Pythagorean theorem to figure out what R is, because we have a right triangle with legs 3 and 4. So 3 squared plus 4 squared should equal R squared. Now, that's 9 plus 16 equals R squared. We add 9 and 16, we get 25 equals R squared. So if R squared is 25 and we take the square root on both sides, that means that R is equal to 5. So we found our R. Now we need to find theta. This is our angle of rotation. We're going to go from 0 degrees, which starts right here. And then we're rotating counterclockwise to our radius right here. So we have to figure out what that angle is. And to do that, we're going to use tangent because we have opposite. The opposite side is 4. The adjacent side to theta is 3. And so we're going to use that tangent to find theta. So the tangent of theta is 4 over 3, opposite over adjacent. We don't have the angle. And when we don't have the angle, we need to use inverse tangent. So inverse tangent of 4/3 is equal to theta. Now we're going to punch that into the calculator. We're going to hit 4 divided by 3 equals, then we'll hit second function tangent. And if we do that, we're going to get that theta is about 53.13 degrees. And so now we have our R and we have our theta. So our answer is going to be 53.13 degrees. Okay, now we have a system of 2 equations and 2 unknowns. We are going to first of all graph these 2 things because they are lines. We can tell that these are linear equations because each of them has x and y, and they're both to the first power or less. So we don't have anything, any variables that are above first power. So those are linear equations. So first of all, in order to graph them, that's the first thing we're going to do is graph. We want to put them in the form y equals mx plus b because that is how we can see the slope and the y-intercept of a line. So we're going to put these in that form. So for the first equation, I'm going to add 3x to both sides. So I'll have 2y is equal to 3x plus 2. And then I'll divide by 2. And so I'll have y equals 3 halves x plus 1. So now I have it in y equals mx plus b form. And I can see that b, the constant, is 1. So 1 is the y-intercept, and so I'm going to put a dot right there on the y-axis where 1 is. So this is what I'm talking about right here, 1. And I put the point on the graph. And now the slope for this line is 3 over 2. That means I go up 3 and over 2 from the point I just put on there. So up 3 over 2 puts me right there. And now I can draw my line. Looks like that. All right, now let's look at the second line, x plus y equals 6. So we're going to get y by itself, y equals negative x plus 6. So now I can see that my y-intercept is 6. So I can put a dot right there on the y-axis at 6. And my slope is negative 1. So I can go over 1 and down 1. And that will be another point on the line. So I can draw the line right there. So those are my 2 lines. And I can see that it looks like they cross at 2, 4. I can't be sure until I solve the system of equations that it is exactly 2, 4, because a graph can only be so accurate. So now I'm going to solve the system of equations. I'm going to use elimination because I can see that I have a negative 3x in the first equation, and the second equation has just an x. And since the signs on those two things are opposites, I think I'm just going to multiply the second equation by 3, and that way the x's will add up to 0 and they will go away. So if I do that, my first equation stays the same, negative 3x plus 2y equals 2. My second equation, I'm going to multiply everything by 3, so 3x plus 3y equals 18. And now I can add the two equations together. The x's cancel, and I end up with 5y equals 20. And if I divide by 5 on both sides, I get that y is equal to 4. So that is my y coordinate, and that looks like it's matching what we got in the graph. And now if I take that 4 and plug it back into either equation, I can find out what x is. I'm going to plug it into the second equation, x plus y equals 6. So x plus 4 equals 6, which means that x must be 2. So I'm getting 4 and 2 for my x and my y. If I want to show that this point works in both equations, I just need to look at both equations and see if it all works out. So if I put in the 2 for x and the 4 for y, I've got negative 3 times 2 plus 2 times 4, which is negative 6 plus 8, and that does equal 2. Now I'm going to plug the points into the second equation, x plus y equals 6. So 4 plus 2 equals 6. Yes, it does. So these do check out in both the graph and the equations, so I know for sure that these are really the coordinates of the point. All right, now we're going to solve this equation that has rational expressions, which look like fractions. And so we are going to do what I like to do first in all these situations, and that is get rid of the fractions. Make them go away, make the denominators cancel. The denominators are 2 and 3. The least common multiple of 2 and 3 is 6. So I'm going to multiply everything here in this equation by 6. I'm going to multiply the first rational expression by 6, the second rational expression by 6, and the constant by 6. If I do that in the first term here, the 2 and the 6 cancel, and I'm left with a factor of 3, which I can then multiply by 5x minus 2. The second term, the 6 and the 3 cancel, and I'm left with a factor of 2, which I can also multiply by x plus 3. And then on the right side of the equation, 2 times 6 is just 12. So if I multiply that 3 by the first term, I'll have 15x minus 6. And then I'm subtracting the next term, which is going to be 2x plus 6. But I'm subtracting it, so I'm going to have to distribute that minus sign to both the 2x and the 6. So minus 2x minus 6, and that equals 12. So now I just need to add my like terms. 15x minus 2x is 13x, and then I have minus 6 minus 6, which is minus 12, and then I still have a 12 on the right side of the equation. Now I'm going to add 12 to both sides, so I'll have 13x equals 24. Divide by 13 on both sides, and you have x equals 24 over 13. All right, so now we are supposed to show that this works in both, in the equation, in the original equation, which is this. So this is the original equation. I'm just going to take 24/13 and put it in for x everywhere I see an x. So 5 times 24/13 minus 2 over 2 minus 24/13 plus 3 over 3, and that equals 2. But, well, we hope it equals 2. We're going to find out if it equals 2. So 5 times 24/13 is 120 over 13, and then minus 2, which is 26 over 13, and that's all over 2. The second part, we're subtracting 24 over 13 plus 39 over 13, because 3 is 39 over 13, and all of that is over 3. Now I'm going to subtract the fractions in the numerator of my first fraction. So 120 minus 26 is 94 over 13, and that's all over 2. And then my second fraction, 24 plus 39, It's going to be 63 over 13, and that's all over 3. Now I'm going to change the first fraction, 94 thirteenths divided by 2 is going to be 94 thirteenths times 1/2. So I'm going to rewrite that. And then my second fraction, 63 thirteenths over 3 is the same thing as 63 thirteenths times 1/3. I can reduce these fractions. I'll reduce by a factor of 2 in the first fraction, and that'll give me 47 over 13. And the second fraction, I can reduce it by a factor of 3, so I'll get 21 over 13, and if I add that up, I'm going to get 26 over 13, which is 2, and that's what it was supposed to be. So 24 thirteenths does work in this equation. And by the way, this was number 12 on your test. Okay, so now we have the square root of x squared minus 8x plus 16 plus 2 equals x. Whenever you have a problem that has a radical in it, the first thing you need to do is isolate that radical, get it all on one side by itself, and everything else needs to be on the other side of the equation. So I'm going to subtract 2 on both sides of this equation, and therefore I will have that whole radical is equal to x minus 2. Now I need to square both sides of the equation, and when I do that, I have to be careful, especially on the right side, that I am not writing x squared minus 4 for that, because that's not what it equals. It equals x minus 2 times x minus 2, which you have to FOIL. So on the left side of the equation, when I square that, the radical, the square root, cancels with the square, and I end up with x squared minus 8x plus 16. And on the right side, like I just said, it is x minus 2 times x minus 2. Now, I'm going to multiply that out. X squared minus 8x plus 16 is equal to x squared minus 4x plus 4. The x squareds cancel. So I want to get all my x's on one side and my constants on the other side. So I'm going to add 4x on both sides and subtract 16 on both sides. So I've got negative 8x plus 4x, and then that equals 4 minus 16. Add the like terms, and you have negative 4x is equal to negative 12. So x is 3 if you divide both sides by negative 4. Now we need to make sure that x equals 3 actually does work in the original equation. And we're going to check that. The original equation is the equation before we did anything to it. So I'm going to leave it exactly the way it is and put the 3 in. And that's very necessary. We can't use any of the other equations we had while we were working on it. We have to go back to the very first equation before we even moved the 2. We want to go back to the very beginning. So we're going to put x equals 3 in there for x. Everywhere we see an x, we're going to put a 3. So we're going to have the square root of 3 squared minus 8 times 3 plus 16 plus 2 is equal to 3. We're going to simplify it. So that's 9 minus 24 plus 16. And that is the square root of 25 minus 24. And that is the square root of 1. And the square root of 1 is 1. 1 plus 2 does equal 3. And so we know that this is the correct solution to this problem. And this was number 16. Sorry, I didn't mention that.